I challenged myself to reverse engineer and code an r/place clone called pixplace.org, an online collaborative canvas where users can log in and contribute to a worldwide pixel grid every 2 minutes. And this is the architecture. I thought I just need a front-end, a back-end, and a database, respectively running Svelte and Vite using TypeScript, Golang with Gin and Gorm, and a simple Postgres database. But to orchestrate these 3 services, I made 3 separate Docker containers and managed these with Docker Compose. For user authentication, I went with Auth0 to make sure data would be secure. But then to protect my back-end API endpoints, I needed to make a JSON Web Token validator that would communicate with Auth0's API. And to live update the canvas, I needed to create a WebSocket connection between the front end and the backend, so that current connected users could receive the new pixels. That's it, right? No. With the repo hosted on GitHub, I decided to deploy my app with a bare-bones AWS EC2 VPS. But for that, I need to distinguish between the dev environment and production environment, managing that with different Docker Compose environment variables and custom scripts. And to secure the request to my app, I went with a Cloudflare domain DNS record pointing to my EC2 IP, and intercept the incoming pings with Caddy, forwarding the upcoming request arriving inside the server to the right ports. Okay. I think that's it. But now, instead of deploying byhead and SSHing into the server every time, I made my own CI/CD pipeline using GitHub Actions to deploy my app according to what branch my code is pushed on. Now we are done. With current existing technologies like Vercel and so on, this is obviously way too over-engineered, but what I learned in this process of doing everything on my own was priceless. Very obviously, this is just a small fraction of what's happening under the hood, and I definitely make more videos like this one about this project and upcoming ones.